Okay, so last time we met, which was a week ago, we were talking about dilutions. The dilution, remember, was just a ratio, and what it was the parts of the concentrate to parts of total solution. So if we were to have a 1 in 8 dilution of, let's say, insulin and water. Oops, if I can write. Then we want to know how much water is needed for 240 milliliters of solution. So if we're looking at this, that 1 in 8 dilution, I always start out by writing my ratio, 1 in 8, and then labeling it. The 1 represents the parts of the concentrate. In this case, the parts of the medications. It's the parts of insulin. And the 8 represents the total solution. We know the total solution, the 240 milliliters, but we're not looking for the amount of insulin, we're looking for the amount of water. We could go ahead and find the amount of insulin and subtract, that would work. Or we could create the ratio of water, or sterile water, to total solution. Well, the total solution is still going to be 8, but if 1 out of those 8 parts is insulin, 8 minus 1, or 7 out of the 8 parts, has to be the sterile water. And that's the ratio we use to find that amount of water. So 240 milliliters of total solution, and we will cross multiply and divide. 7 times 240 divided by 8 is 210 milliliters of NS to complete that solution, that dilution. And of course, that means the other 30 milliliters was the insulin. We also looked at doing urine testing or blood testing where a concentration exceeded a meter. And we used the dilution in order to make that testing work. So for example, let's say we have a test where, again, we exceed a meter on a blood test. So we decide we mix 40 microliters of blood with 200 microliters of sterile water. And now the new test result yields 184 milligrams per deciliter. We defined the true result. So the first step here is to figure out what dilution was used. Remember, the dilution is always concentrate. In this case, that would be pure blood to total. So here the concentrate, the pure blood, is 40 microliters. But what goes on bottom is not the 200. 200 is just the NS. So it's got to go on bottom is going to be the 200 plus the 40 microliters. So giving us 40, the microliters will cancel out, so it gives us 40 over 240, or a 1 in 6 dilution. Once we know the dilution, then we have to think about, based on our test result of 184, would the actual non-diluted result be lower or higher than that? And of course, since we know this exceeded the meter, we know the actual result is high compared to what our test result is. So that means the 184 is going to be compared with the 1, and the true result is going to be compared with the 6. So you would cross multiply and divide. 6 times 184 divided by 1 is going to give us 1,104 milligrams per deciliter. Well, for today then, we want to start looking at adjusting solution concentrations. We started on this a little bit last class. Let's say we have 24% solution. And let's just say we have 480 milliliters of that solution. And we need 6% solution. To figure out how to dilute this down, let's take a look. Let's start out with the 24% of the 480 milliliters of the 24% solution. Well, 24% of 480 is going to give us, well, 24 times 480 divided by 100. Oops, that's not right. 115.2 milliliters of the concentrate of whatever that serum is, the medication is. Well, to make that an equivalent 6% solution, we still have 115.2 milliliters of concentrate. If we cross multiply and divide, we would have to have a total volume of 1,920 milliliters. In a dilution, of course, if we were to dilute this solution, the 480 milliliters of 24% is going to become the concentrate, because that is the higher concentration. After we dilute it, the 920, or 1,920, I should say, will be the total volume, or total solution at the 6%. So the dilution here is 480 milliliters over 1,920. Reducing that down, of course, both of those can be divided by 10, giving us 48 over 192. Both of those can be divided by 4, giving me 12 over, what is that, 58. We can keep going. Actually, that's not right. 12 over 48, not 58. And both of those can be divided by 12 to give me 1 in 4. So this is a 1 in 4 dilution. To reduce 24% to 6%. Well, looking at this, you can see that the actual ratio, the dilution needed is set up as the new percent, the diluted percent, over the old, or the concentrated percent. 6% over 24% is going to be 1/4, or 1 in 4. So if we were to ask what dilution is needed to dilute, let's say a 32% solution to 12%. Well, what that means is we're going to take the 12%, that's the diluted percent, over the concentrated percent, the 32%. The percents, of course, cancel out. 12 and 32 can both be divided by 4. That's going to be 3 and 8 dilution. So let's say we have 360 milliliters of a 68% solution. We need a 17% solution. How much sterile water do we add to dilute that down? So that's our question, is how much sterile water to add? Well, the first thing we're going to do is we're going to look at our dilution, figure out what dilution is necessary. So again, we're diluting it down to a 17% from 68%. Both of those can be divided by 17 to reduce to a 1 in 4 dilution. Now that we know that our dilution is going to be a 1 in 4, we can adjust that. Remember, the 1 is going to be the concentrate, or in this case, the 68% solution. The 4 is going to be the total solution, or total volume, of the 17%. Well, we don't want to know how much of the, or how much total solution we have. We want to know how much water to add to that 360 milliliters of the 68%. So we still want the 68% solution, but we want to know how much water to add to that. So if it's a 1 to 4 ratio of 68% to total solution, there's still one part of the 68%, but out of the 4 total, the other 3, 4 minus 1, gives us 3 parts of sterile water that is added to it. So we have a 1 in 3 ratio. The 360 milliliters represents the 68% that goes on top. We cross multiply and divide. 3 times 360 divided by 1 is going to give us 1,080 milliliters. Now that is not the total solution. Remember, the 3 here represents the sterile water that is added, neutral solution. The total volume, if we had wanted that, we didn't ask for it in this problem, but the total volume would be 1,440 milliliters. But in this case, we're just looking for the amount of NS. Well, let's look at a slightly different angle. Let's say we need an 18% solution. And we have 45%. Well, let's say how much 45% and how much water to use to create 720 milliliters of the 18%. So again, our first step is going to be to figure out what the dilution is. And our dilution, when we're adjusting the percents, we're going to diluted percent of 18%, concentrated percent of 45%. Both of those, cancel the percent, both can be divided by 9. Gives us a 2 in 5 dilution. So that 2 in 5 dilution, of course, the 2 is the amount of the concentrate, the 45%. The 5 is the total solution, which of course is going to be the 18%. But we do want to know how much of the 45% solution to use, and we have the total volume is going to be 720. So we'll put the 720 milliliters on bottom with the total volume, and we'll cross multiply and divide. 2 times 720 divided by 5 is going to give us, I believe, 288 milliliters. Let me double check that. That is correct, 288 milliliters. Now at this point we could subtract to get how many milliliters of water we'd put in there, or we can adjust. If 2 out of 5 parts is the concentrate, we still have 5 parts total, minus 2, the other 3 parts is going to be the water. Oops, NaNS. And we set up that proportion with the 720 milliliters total volume. And we will cross multiply. 3 times 720 divided by 5 is going to give us 432 milliliters. So to answer our question, is 288 milliliters of the 45% solution and 432 milliliters of sterile water. Now what we just did here is kind of the long way of going about, well, let's do this. Let's look at another problem before I show you the shortcut. Let's say we have 240 milliliters of a 72% solution. We are going to add 720 milliliters of NS. Find the new concentration. Notice the new percent. Well, to find that new concentration, we need to figure out what the dilution is. And our dilution, of course, there's 240 milliliters of the 72%. That's the concentrate. But the other number needs to be the total volume. So in our total volume, we had still the 240 milliliters plus the 720 milliliters that we added of the sterile water, the NS. So what that gives us is 240 to 960. Reducing that fraction, both divided by 240, give us a 1 in 4 dilution. Once we have that 1 in 4 dilution, we can just do a proportion to find our percent. We know that 72 is going to be the concentrated percent. That's going to go on bottom with the 4, because the 4 is the bigger number, and we'll cross multiply and divide. 1 times 72 divided by 4 is 18%. So that new solution will be at 18% after being diluted with 720 milliliters of saline or sterile water. So again, as I mentioned, this is kind of the long way of going about it. There's a shortcut formula that has come out of this based on what I just did here. If we look at a dilution, it can be described in one of two ways. It can be described as the volume of the concentrated percent to the diluted volume, but it can also be described as the lower percent, the diluted percent, over the concentrated percent. Those two ratios are going to be equal. Now what you'll see here is that this is an inverse relationship, because the concentrate is on top on this ratio and it's on bottom on the other ratio. As the concentration gets higher, the volume has to get lower. Or probably the more reasonable way to look at it is the volume gets higher, the concentration gets lower. If we solve this, do some algebra, we multiply both sides by the concentration percent and both sides by the diluted volume, what we end up with is the concentrated volume times the concentrated percent, we use C for concentration, is going to equal the diluted volume times the diluted concentration, or diluted percent. In order to avoid the confusion of having the C's and D's as our subscripts, we usually just write it as volume 1 times concentration 1. So the original volume times the original concentration. is going to equal the new volume times the new concentration. And again, that comes from solving this proportion with our dilutions. Well, another way of looking at it, if you recall back when we first started talking about concentrations and diluting, when we were doing the algebra with the big equations in Unit 2 to solve for diluting a formula or combining two different concentrations of solution, we looked at the amount of serum in a solution was equal to the volume times the concentration, the volume times the percent. So as long as all that we are adding to this is water, the amount of serum should be the same on the other side. So even if the volume goes up, the concentration goes down so that the total amount of serum is not going to change. So let's look at some of our problems using this shortcut formula to solve instead of just using the simple dilutions. So let's say we have, let's just say we're going to have 300 milliliters of 45% solution. How much 9% solution will this make? Okay, well, we're looking at this. We have our original volume is 300 milliliters. I'm just going to use 300. Our original percent is 45%. Now I could put in 0.45 as a decimal here if I wanted to, but I don't have to since there's a percent on the other side of the equation as well. As long as I write them both as percents, I don't have to worry about changing them to decimals. So I'm going to leave it as just 45 here. On the other side, I'm looking for the volume. So this is my second volume, V2, times that percent of 9%. And again, I'm just going to write it as 9 so I don't have to work with the decimals. So I've got 300 times 45 is 13,500 equals V2 times 9. We're going to solve by dividing by 9, which is going to give us 1,500 equals V2. Now we have to be careful here with our units. We have to go back. What was the units on the V1? Well, the 300 was 300 milliliters, telling us that V2 here is also in milliliters. It's 1,500 milliliters. Another way we could look at this is, let's say we have 72 milliliters of 48% solution. It is diluted to a volume of, let's go 504 milliliters. Find the new concentration. Well, so again, V1 times C1 equals V2 times C2. We're going to let the 48% be our first solution here. 72 milliliters is the volume times 48% is the concentration. So 72 times 48. The volume of the second one is 504 milliliters times its concentration. I'm just going to write C there so I'm not confused with the 2. It is C2 technically. So to solve this, we have to do 72 times 48. 3,456 equals 504 times C. We're going to divide by the 504. So 3456 divided by 504. 6.86% is our new concentration. Any questions so far? Okay. So you can see how this formula saves us a lot of work over just using the dilution formula to mix these and dilute these solutions. So let's say that we have, let's say we have a 64% solution. And we need to dilute, or let's put it this way. How much 64% solution do we need to mix with how much sterile water to get 400 milliliters of an 8% solution? So again, we have the 64% solution. So I'm going to let that be my first solution. I'm going to write up my formula. V1 times C1 equals V2 times C2. So the 64% is my first concentration. I don't know that first volume, so I'm looking for V1 as one of the things I need to find. On the other side over here, V2, I have 400 milliliters of the 8% solution. So C2 is 8%. So I have 400 times 8 is 3,200 equals V1 times 64. I divide by 64. Should give us 50. Oops, sorry. I left a 0. Should give us 50. So that V1 is 50 milliliters. Well, remember what that is asking. Of course, we got the milliliters off there because it was 400 milliliters. V1 was representing the 64% solution. So that is saying we need 50 milliliters of the 64%. But that's only half of our answer to this problem. It also asked how much sterile water, or how much neutral solution needed to be added to that. To find that, we had a volume of 50 milliliters of 64%. We got 400 milliliters of the 8%. The only thing that could make up that difference in volume is our saline, our neutral solution. So 400 milliliters minus 50 milliliters equals 350 milliliters of the sterile water. Now that is one of the weaknesses of this formula, is this formula, the V1C1 equals V2C2, only solves for the amount of the concentrate. It cannot solve for the amount of the sterile water. Like in the dilution, we could set up the different ratios based on that dilution ratio that gave us the amount of water directly. In this formula, we have to count on just subtracting volumes to get the amount of water or saline to be added. Well, let's say we have 240 milliliters of the 32% solution. If we add 1,080 milliliters of sterile water to it, find the new percent. So here we've got V1 times C1 equals V2 times C2. We have our V1 is the 240 milliliters times C1 is going to be the 32%, so just 32. On the other side, it doesn't look like we know anything. What we're trying to find is the percent, so that's going to be the C2, which means we must know the V2 from somewhere. If we look at it, we've got the 1,080 milliliters of sterile water or neutral solution, but that's not the total volume. That is being added to the 240 milliliters. So this is going to be 1,080 plus the 240. This is going to be the volume times C2. So over here, we're going to do the 240 times 32. 7,680 equals 1,080 plus 240 is going to be 1,320 times C2, and we'll divide by 1320. Giving us 5.82, basically, if you round that off, percent is our new concentration. Okay. Let's do a couple more examples here. Let's say we need to make 800 milliliters of a 22% solution. We have 40%. So let's figure out, how are we going to make this? What are we going to do to mix this? So we're going to start out again with our concentration formula. We have 800 milliliters will be V1 times C1 is 22%. We're going to get that from the 40%. We need to know the volume of the 40%. Now here you might be thinking, well, isn't the 40% what we started with? Yes, we could have made that our V1 if we wanted to. It really doesn't change the formula. V1 and V2 are interchangeable as long as we keep the concentration with its volume. So anywhere here, 800 times 22 is going to be 17,600. Let me just double check that because my internal calculator hasn't been working so well this morning. So 17,600 we're going to divide by 40. So we divide by 40, we get 440. Equals V2. Now that is 800 was in milliliters. So the 440 is also in milliliters. And that represents, V2 was with the 40%. So that is 440 milliliters of the 40%. To finish that problem up of how we're going to mix that, we still need to find the amount of saline or sterile water. Well, to get 800 milliliters total, if we're using 440 milliliters of the 40% solution, we subtract, that means there's 360 milliliters left of the saline or sterile water. Any questions? Okay. Well, let me do one or two more examples for you, then we'll let you guys out of here for the day. Actually, just giving you a little bit of foreshadowing, by the way, this week. We do have a full week this week, all 3 days. Next week, looks like one of the schools is out for spring break all week next week. So the plan is this week we're going to get our lessons in on dosage calculations as much as possible. Next week we'll talk a little bit about loading syringes, and we'll do some examples on Monday of next week on our dosage calculations. Next week, Wednesday, it's still up in the air as to whether we're having class or not, but I'll let you know here in the next couple of classes. So for those of you that do have spring break all of next week, next Monday, we'll just be doing applied problems on the stuff we talked about this week. Wednesday, like I said, if we do have class, it'll be more applied problems, more examples of stuff that are similar to the calculations we're going to do. So it would be very much to your benefit to watch the videos if you can, but there won't be any new homework next week because of that. Okay, so anyway, let's do another example of using this formula before we get out of here. So let's say that we are going to mix 300 milliliters of 60% solution with NS to get a total volume of 4,500 milliliters. Find the new concentration, new percent. So we have 300 milliliters of 60%. Let me start out with my formula here. We can treat those as our V1 and C1 here. So 300 milliliters times 60%. On the other side, we got the 4,500 milliliters. So the first thing we need to do is we need to make sure, is that the amount of sterile water or saline used, or is that the total volume of that new solution? And if we read here, it says to get a total volume of 4,500 milliliters. So that is our total volume. So 4,500 milliliters times C2. So to solve, 300 times 60 is 18,000 equals 4,500 times C2. And we divide by 4,500. Giving us 4 equals C2. So this is our concentration, so that is a 4% solution. This is what we get if we dilute that down to 4,500 milliliters. Okay, we've only got about 5 minutes left here, so let me go ahead and give you your homework. Your homework out of the book will be page 134, 1 through 11, the odds. That's going to be talking about the dilutions and using the dilutions to change concentrations, or what dilution is required to change from one concentration to another. Also on page 138, 1 through 17, the odds are going to be on this concentration adjustment formula. Now, one thing in this section that we didn't necessarily go over with the dilutions, let's say that we have, let's just say we have a 72% solution. And we take it through, we perform a 3 and 8 dilution. Find the new concentration, the new percent. Well, in a case like that, I mean, we've done all the stuff we need to make this happen, but just to show you the shortcut, we know that the 3 and 8 is the new percent over the old percent. So if we just take our 72%, the old concentration, and multiply by that dilution of 3 and 8 as a fraction of 3/8. So 72 times 3 divided by 8 should give us 27% would be our new concentration. Okay, with that, I will let you guys out of here. That is your homework for Wednesday. We'll see you all on Wednesday.